So transfer learning allows me to take an algorithm that might have been brittle on my data and make it more generalizable to my
Exactly.
patient population.
Right.
And how exactly is it doing that?
In a transfer learning situation, you take the network and the weights that were created on the original data set, and you show it examples of your data, and it sort of learns how to adapt the weights for the data that you now have.
So if I take that new algorithm and go back to the original institution,
it's a
will
good
it
question.
work better?
It's not necessarily sure that it will work better. There's a number of other methods that are being created in the research field, such as federated learning or distributed learning, that allow you to learn more globally across multiple collaborating institutions. And that's a fairly exciting application of deep learning, is that if you can have enough data from different institutions and learn jointly on all of these data, you get something that's fairly robust. What we have seen, even in this data set, is that a algorithm that was trained on institution A, when you applied it as is without any changes to institution C, performed horribly. And we know that there's differences in the protocols and how the acquisition happened between these different acquisition systems, and so we expect some of these differences, but it's fairly striking how an algorithm performance might degrade when applied to data set that it was not really trained for. What we can also then do is something like transfer learning, where we don't need to start with all the cases all over again. With a few more cases, we can improve the performance.
So when it comes to this collaborative approach of creating algorithms, there seems to be a lot of different terms out there: transfer learning, federated learning, split learning, ensembles. Are these just all different techniques that are being tested right now? Is one the best? Is one better than the other?
Again, really good question. I think they're all being tested right now, and potentially, depending on whom you ask, you might get very different answers in the research field. The idea with them, some of these techniques is essentially, as you mentioned, you start with one institution, you try it on something else, and if you do it just once, it might be transfer learning. But the concern is, and now it's really fine-tuned for institution. The second institution, it may not work again if you go back to institution A. In a distributed and a federated learning system, you actually pool all of the data together so that it's jointly learning a model that works well for all of the institutions. And we actually see that in our mammogram case as well. When we created a model that was trained using all of these different data sets together, it performed really well for all of the different institutions.
And it performed better than it would for the one that was personalized for that particular institution?
It depends on how many cases you have, but it can perform better because it's seen a lot more data and a lot more robustness of the appearance of the images. So that's one approach, is some kind of a federated learning. In this particular case, you can just pool all of the data because we happen to have them in a central location. That may not be the case. If you and I are collaborating and we're at different institutions, we may not be able to send our data somewhere else to have it jointly learned. So we are working on ways to try to learn jointly without the data leaving the institution.